Hey dear kiddos, how are you? This is Varsha and I'm back with another session on determinants. Today we will be revising everything related to the topic determinants quite in detail. Be ready, and towards the end lot of questions on determinants. What is the most important thing about determinants chapter? It's the properties of determinants, right? Determinants being closely related to matrices. I believe you all have gone through the summary session of matrix chapter, which is already there on the channel. Guys, I would really love to know what's your feedback, whether you're understanding the session, you're not understanding, you want some improvement, you're liking it, disliking it, all of them I will be interested to know. So please write down in the comment section and it will be read by me. Let's begin the session with a beautiful smile, guys. Introduction to determinants. So introduction to determinants. What do you mean by determinant? What do we understand by determinant? So in simple words, determinant is a number associated with a matrix. Number associated with a square matrix. Let me be specific here. Square matrix. Why square matrix? The row and column will always be equal. In determinant, it is represented by the capital letter D, delta, or this sign, this vertical lines. Now do not get confused by considering this as a mod. It's not a modulus sign, it's determinant. Order of a determinant. Unlike matrix, which has number of rows and columns specified, your number of rows and columns are always same, so we just write n equal to 1, n equal to 2, n equal to 3. 1 will mean it has 1 row and 1 column, suppose the element 3 in it. 2 will mean it has 2 rows and 2 columns, 5, 2, minus 3, 0. 3 means it will have 3 rows, 3 columns, that means a total of 9 elements. Similarly, nth order determinant can also be formed with n rows and n columns. The second aim after understanding that it's just a number related to a matrix, we will find what is that number. It comes under the topic expansion of determinants. Let's all see how do we expand a determinant. For order 1, guys, for order 1 the expansion is very easy. For n equal to 1, if this is your determinant, let's say d equal to minus 3, right? Or if a matrix A is given like this, minus 3, what will be the value of determinant? It will be minus 3. Same. For n equal to 2, suppose a matrix is given as minus 5, 2, 3, 6, then its determinant is product of diagonal minus product of off diagonal. You know diagonal is this, off diagonal means the other one. Product of diagonal minus 5 into 6 minus product of off diagonal, minus 30 minus 6 minus 36. Am I right? Yes, but when it comes to order 3 expansion, how many ways can you expand the given determinant of order 3? So in the chapter in physics, we have done a lot of times expanding a determinant. There are 6 ways to expand a given determinant of order 3. That means by 3 rows, R1, R2, R3 and 3 columns, isn't it? What helps in expanding a determinant? This chart. This chart will help you while you're expanding any determinant. If you're expanding in row 1, first term positive, second negative, third positive. If you're expanding along column 2, first term negative, middle term positive, last negative. So this chart will help us, guys. But where should we actually expand? Out of 6, where should we expand? You expand along any row or column, the final answer will remain the same. You expand along row 3 or you expand along column 2. The answer will remain the same. Expand along row or column which has maximum number of zeros. That is preferable. If there is no 0, then it's your choice. But if there is 0, then why not expand along a row or column which has more number of zeros? It will make the expansion very easy. So can I assume that all of you know expansion in physics? You have done a lot of times. If not, further in the questions, we will be coming across expansion of determinants, right? Next topic is minors and cofactors. What is minor in a determinant? It's written as Mij. That means number of elements, those many number of minors are present. Mij is obtained by deleting ith row and jth column. Anybody has any confusion, it will be cleared. Wait for a moment. And next thing is cofactors, written as Cij, also a capital Aij. And it is nothing but minus 1 raised to I plus j times Mij. Cij is minus 1 raised to I plus j times Mij. Let's take an example, short and simple one, order 2. 3, 2, 5, minus 1. Okay, this is your given matrix. We need to find all the minors. M11. Now for finding M11, you will delete the first row, first column and write down whatever is left. M12. Delete the first row, second column. M21. Deleting the second row, first column. And M22. Second row, second column, deleted, hided, you will get all the minors. Can you see deleting? And so it is nothing but determinant obtained. It is nothing but determinant obtained on deleting ith row and jth column. If it's a 3 by 3 matrix, if it's order 3, in that case when you hide a row and a column, whatever is left, solve that determinant. We will be going only till order 3, that's the good part. No order 4. Well, let's calculate the Aij also. Now, simple way to calculate the cofactor is, cofactor will be same as minor if this I plus j is an even number. And cofactor will be negative of minor if I plus j gives you an odd number. All you have to do is add them and check even or odd. 1 plus 1, 2. Even number, cofactor will be same. 1 plus 2, 3. Odd number, cofactor will change its sign. This is A11, this is A12, cofactor changing its sign, 5 becomes minus 5. A21, 2 plus 1, 3, an odd number, this 2 will become minus 2. And last one will give me 2 plus 2, an even number, 3 remains 3. Can you all see? A determinant, cofactor, minor. Now what is the significance of this minor and cofactor? Why are we studying suddenly about minor cofactor? That's because the definition of determinant is related to minor cofactor. How come? The definition of determinant says delta is nothing but summation of Aij into Cij. That is, it is equal to sum of product of any element with its cofactor. Example, delta is equal to A11 C11, A12 C12, A13 C13. Can you see this is expansion along row 1? Similarly, if you are expanding along column 2, let's say we are expanding along column 2, so you take the elements of column 2 and multiply by its own cofactor. No other cofactor, its own cofactor. Column 2 elements will be A21, A22 and A23. Multiply with its own cofactor. What will happen if you multiply with some other cofactor? Suppose you are not taking 2, 1, 2, 1, 2, 2, 2, 2, 2, 3. You are taking some other number. What will you get in that case? You will get a 0. You will get a 0 if this is not equal. Example, A11 and C21 plus A12 into C22 plus A13 into C23. Can you see the elements are of first row, the cofactors are of second row. so the elements and cofactors are not of the same row or same column, then such an expansion will give me answer to be 0 always. Please remember, I'll be writing this as a property towards the end of the session, end of the summary also. Hope this definition part for a determinant is clear. Now what is the next very important segment? That's your properties of determinants. Most of the question that you get is on properties. Majority of the questions will be based on properties. And yes, it's a fact that questions on properties are difficult to solve. Questions on properties will give you some pain initially. All you have to do is have patience. Yes, there is no other funda. Have patience, practice a lot of questions. When you will be practicing a lot of questions, that's the only way you will be able to crack the questions based on property. Also simple, some smaller tricks here and there which definitely helps to crack the properties. The very first property, I'll be giving keywords and writing all the properties in short. Not writing those big statements. You can open your textbook, refer them. I am not going to do. The very first property says determinant of A is same as determinant of A transpose. That means when you interchange any two row or all the rows and columns, what is transpose? Interchanging the row and column. When you interchange the row and column, you will get the same determinant. Determinant doesn't change. Second property says if you interchange any two rows or any two columns, that means you do like this, Ri changes to Rj, and you are interchanging Ri and Rj, or you are interchanging Ci and Cj. What will happen in such a case? If you are interchanging any two rows or any two columns, the sign of delta will change. The sign of determinant changes. If it's positive, it will become negative. If it's negative, it will become positive. That means if you're doing this transaction, if you're doing this transition n number of times, then delta n is equal to minus 1 raised to n times delta, where n is number of times interchanging them. Number of times you interchange. Example, n is equal to 1. Suppose you are interchanging any two rows. You are doing it only once. So delta 1, the new delta will be equal to minus 1 raised to 1, which is minus delta. If you are doing 2 times the transaction, once you interchange row 1, row 2, now you are again interchanging row 2 and row 3. So in a particular determinant, if you are doing 2 times this kind of interchange, what will happen? Minus 1 raised to 2 is same as delta. You will get back delta. So you started with delta. Initially it was delta. One transaction will make it minus delta. Another transaction will make it plus. Once again minus delta. Once again plus delta. So the sign keeps on changing depending on how many times you are interchanging rows and columns. That's your second property. Hope it's very clear to all of you. Shall we move to the third property, guys? The third property and a simple property. It has 2 parts. First one, if any two rows, and whatever is applicable for a row, applicable for column also. Any two rows or columns are same, then delta will be 0. Without solving, if any two rows, any two columns are identical, delta will be 0. Part B says, if any two rows or columns are in proportion, then also delta will be 0. That means if suppose you have a determinant like this, 3, 6, 9, here you have 6, 12, 18 and anything, minus 1, 11, 15. Can you see row 1 and row 2 are in proportion? 3 by 6, 6 by 12, 9 by 18 is 1 by 2. Two rows are in proportion, the answer will be 0. That's your third property. Fourth property, guys. Actually, this is itself your fourth property. Let's say this first one is third, this is fourth. I'll go to the fifth one. Not A and B. Let's name it. Different books have different number of properties. To keep it simple, we will give it a new name. Fifth one is like your split property. What splitting happens? Any given row can be separated into two different, or any given column. Example, you have x1 plus a, x2 plus b and x3 plus c. Here we have a1, b1, c1, a2, b2, c2. Can you see the row 1? If I split row 1 into two parts, the first part will have x1, x2, x3. Second part will have a, b, c. Rest of the two rows remain as it is. So your row 1 is divided into 2. Can we similarly do for column? So any column, if it's given into two parts, example x plus a, x1 plus a, x2 plus b and x3 plus c. Rest everything is a1, b1, c1, a2, b2, c2. Can we divide it into two parts? Of course you can do that also. Your row 1, first it will have x1, x2, x3. Next part will have a, b, c. Rest of the columns remains same. Rest of the columns remains same. Do you get the fifth property? Yes, it is useful while solving questions. Last two properties left. What is the sixth property and seventh property? The sixth property says that whenever you multiply a determinant with a constant, the value of the determinant altogether gets multiplied with it. Example, this property is like this. Determinant of Ka is same as k raised to n times determinant of A, where n is nothing but order. You have a determinant 3, order 2 we will take, it's easier. 3 minus 1, 2, 6. Right? What is its delta? 3 6 are 18 plus 2, 20. Now if I want to do 2 times delta, will the answer be 40? What will it be? If I am doing 2 times delta, will this 2 be multiplied with each and every element? Will this 2 get multiplied with each and every element, or it will be multiplied with just one row or just one column? Yes, here comes the important part. If you are doing 2 times delta, this number 2 will get multiplied either with any row or any column. It will not get multiplied with all the elements. So suppose I am taking 2 with row 1, 6 minus 2, 2, 6, 6 6 are 36, minus 2 2s are 4, plus 4, 40. Can you see? Delta 20, 2 delta 40. But how are we getting 40? Only row 1 is getting affected. Only row 1 is getting affected. You should not multiply 2 with all the elements. Point to be noted, my lord. And last, elementary transformation. Last one is elementary transformation. It's same like your matrices. Elementary transformation is similar to your matrix chapter. Whenever you do transformations like this, Ri changes to Ri plus k times Rj, or Ci changes to Ci plus k times Cj, your determinant will not change. I mean, before this transition it was delta, after the transition also it will be delta. Before this, after this, the delta value will not change when you do such transitions. The only thing you have to remember is, don't try to mix up both the transitions in a particular question. In one question, go for either row or column, else you will mess up big time. Is all the 7 properties absolutely clear, guys? Very, very clear? Great. So moving on to the next part. What is the next part after doing the properties? Hell lot of questions are there on properties. We'll come to it. Application of determinants. Application of determinants. Let's see what are the application of determinants. The first one we all know, it's there in our NCERT. The first application is to find area of triangle ABC. If all the three vertices of the triangle are given to you, let's say the vertices are x1, y1, x2, y2, x3, y3, then area of such a triangle, you don't have to use hero-heroine formula or some other formula. We can directly find out half x1, y1, x2, y2, x3, y3, 1, 1, 1, and put it all together in a mod because area can't be negative. So that's an application of determinant. What will happen if this area comes out to be 0? If this area comes out to be 0, then what do we conclude? Or this determinant x1, x2, x3, y1, y2, y3, 1, 1, 1. If it is 0, that means points are concurrent. Points are concurrent. Now a edge. While solving question on this type, area of triangle is equal to this. While you're solving a question of area of triangle, finding area of triangle is easy. Two types of questions you can expect. First, find area of triangle. Now that's very easy. But second type of question is find one of the coordinates. Find one of the coordinates, like x2 will be hidden. They will say x2 is k, find out k. Everything else is given. Just one element of the coordinate will be hidden. You have to find that. Now whenever you have to find one of the coordinate, or let's say find k, mostly it's k, you have to remember while you're removing the mod, plus minus sign should be taken. Example, the area given is 40 and you have half. You have substituted all the values nicely, like 3, 2, minus 1, 0, k, 5, 1, 1, 1. While you're solving it further, the first step will be to remove the mod. To remove the mod means to put plus minus 40 is equal to half of given determinant. 3, 2, 1, minus 1, 0, 1, k, 5, 1. Taking 2 on the other side and then solving. That means you will get two values of k possibly. You will always get two values for a coordinate. If it is unknown to you, you will get two values of a coordinate. I have kept, yeah. Are you able to understand the two types of questions we expect on this? Next, what is another application? Only these two applications present in the textbook. There is one more application kind of question you see in NCERT exemplar, and that's finding area of a straight equation of a straight line. Equation of a straight line. Can we find equation of a straight line using determinants? Yes. How? X, y, 1, x1, y1, 1, x2, y2, 1. Everything is same. x1, y1, x2, y2 is nothing but the point joining two points. Line joining 2 points. And xy is for forming an equation. That's another application. Fourth application, oh, there is more application. Yes, the next application is to solve system of linear equations. So from here you must be understanding what is the next topic I am going to pick up. Linear equations, system of linear equations. When you have more than one equations, how to solve them, how to find the value of x, y, z, whether a solution exists, doesn't exist, all that is also found with the help of determinants. Let's write down. Kramer's rule is also one of the application of determinants. I think that's it. I'll stop the application of determinant, move to the next topic. The next topic is adjoint and inverse. Now, why do we find adjoint and inverse at all? The adjoint and inverse is found. Adjoint is found so we can find inverse. Inverse is found so we can solve system of linear equations. That's the only purpose for solving system of linear equations. Adjoint is given by ADJA. Adjoint of any matrix A is given as ADJA. and adjoint is nothing but cofactor transpose. When you take the transpose of cofactor matrix, you will get an adjoint matrix. Now in market there are different ways to find the adjoint quickly or to find the inverse quickly. I mean, if you spend that much time on YouTube finding what is the shortest way to find adjoint, firstly you will spend half an hour to understand what is the shortest way. Instead, I would recommend go directly solve it. The most happening trick which I feel is, yes, remembering this chart, nothing else. Wherever there is plus sign, you will find the minor and write it as it is. Wherever there is minus sign, you are going to change the minor, right? Plus denotes same as Mij and minus means change the sign of Mij to get Cij. Yes, for order 2 there is a shortcut. What is the shortcut to find adjoint of an order 2 matrix? Example, this is 2, 3, 6, 1. If we want to find its adjoint, you interchange the diagonal elements and change the sign of off diagonal elements. What do we do? Interchange diagonal, and for off diagonal you will just change the signs. Off diagonal, which is not the leading diagonal, not the principal diagonal. Off diagonal you don't have to change off diagonal, just the main diagonal you have to interchange. Remaining, change the sign. For order 3, no shortcut, just find the cofactors and transpose it, right? Okay, there are certain properties of adjoint which we will write down, a couple of them. Property 1, adjoint of A into A is equal to A into adjoint A, and that's equal to determinant of A into I. That means it will give me a diagonal matrix. When you multiply any adjoint with its matrix, you will get the answer as a diagonal matrix. Property 2, determinant of an adjoint matrix is equal to determinant of A raised to n minus 1, where what is n? N is of course the order. So guys, when you know the matrix A, find its determinant and quickly get the determinant of adjoint. No need of finding adjoint to find its determinant. And the third one, reversal law. Adjoint of A into B is equal to adjoint of B into adjoint of A. Do you remember the reversal law was there in matrix also? It's there everywhere. So reversal law is applicable here also. Okay. Next one, after adjoint. We use this adjoint to find inverse. Of a matrix. Now, inverse we have found in matrix chapter also. Inverse is found in matrix chapter also. What is the difference here and there? Which one is easier? Now, it depends. If it's order 2, both are easier. Elementary transformation is also very easy. This method is also very easy in determinants. If it's order 3, I would go for depends again depends. If it's order 3, finding adjoint means finding cofactors for 9 elements, then transposing it, then finding determinant, and sometimes elementary transformation becomes easy. Depends where you see the hint, है ना? So practice your hands on everything, both the methods. In a question, if they have mentioned solve or find inverse by elementary transformation, then you have to do that. If they have not mentioned anything, they've just asked you to find the inverse, it's your choice. You can do by method that I'm telling you now, or you can do by elementary transformation. Choice is open, you can do whatever you want. Inverse. A inverse is obtained by the formula 1 upon determinant of A, adjoint of A, into adjoint of A. This calls me for a need that denominator shouldn't be 0. If denominator is 0, that means determinant is 0, it is called as a singular matrix. And if determinant is non-zero, it is called as non-singular matrix. Now tell me, for finding a inverse, which type of matrix do we need? Singular or non-singular? Of course, we need a non-singular matrix. So inverse is only found for non-singular matrix. Before finding inverse by this method, always check whether it's non-singular or not. Also, the inverse which you obtained is unique. Every matrix has an inverse, unique inverse. That's the formula for finding or calculating the inverse. Remember, determinant of A inverse is same as determinant of A, the whole raised to -1. Just take the reciprocal of determinant A, you will be getting determinant of A inverse. Determinant of A transpose, we already wrote, it's same as determinant of A, the whole transpose. Right, boys and girls? Okay, now moving on to the next segment, which is not in CBSE. It's not in CBSE. Kramer's rule. You must have studied it in your lower standard. I'm not sure about it, but very useful if you have to find the value of x, y, z for a system of equations in competitive exams, not in CBSE. Useful to mention, just like in limits, the L'Hopital rule is not in CBSE. Similarly, this Kramer's rule is not in CBSE, but we should know it's a shortcut method for solving equations. Suppose we have two equations like this. A1x plus b1y equal to c1 and a2x plus b2y equal to c2. We want to solve these two equations and get the value of x and y. You have studied the consistent inconsistent method. This is other way. D. What is D? D is nothing but x is given by the formula dx upon d. Y is given by the formula dy upon d. What is dx? What is dy? What is d? Let's understand. D is, when you remove xy, a1 b1, a2 b2. Dx is, in this, instead of a1 a2 you will write c1 c2. For dx, remove the coefficients of x. For dx you will remove the coefficients of x and replace it with c1 c2. For dy you will remove the coefficients of y and replace it with c1 c2. Rest everything is same. This is a1, this is a2. Instead of b1 b2, I have just written c1 c2. Find d, find dx, find dy, substitute here, you will very easily get x and y. This is for two variables. If you have for three variables, a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. If these three equations you have to solve and find the value of x, y, z, x will be equal to dx upon d, y will be equal to dy upon d, and z will be equal to dz upon d. Where what is d? Now this time it will be order 3. You, for finding d, you just write all the coefficients a1 b1 c1, a2 b2 c2, a3 b3 c3. For finding dx, what is dx? You will hide the coefficients of dx and write everything b1 c1, b2 c2, b3 c3. In place of x, the constant comes d1 d2 d3. Now you have got an idea. Try writing for dy and dz. Try to write for dy and dz. The only difference is in dy, the middle y, in place of x, y, z, y will be replaced with d1 d2 d3, and in dz the last position will be replaced with d1 d2 and d3. Rest everything is same. Isn't it nice? Very good. Find this 4 determinants, substitute, you get the answer. Well, What if it's a question in CBSE? We won't be able to use Cramer's rule, and in such a case, we have system of equations. System of linear equations. System of linear equations. Let's try to solve the system of linear equations. There are two types of solutions available. One is consistent, the other is inconsistent, right? Okay. So one type of solution is consistent and the other type is inconsistent. One type of equations are consistent, the other type is inconsistent. Consistent again has three parts. Make this chart. All your questions of this consistency, inconsistency will be solved within seconds with the help of this chart. This has three types. One, unique solution. If the solution exists, it can be unique, or it can have infinite solution, or it can have a trivial solution. Now what do we mean by a trivial solution? It's a special case. It's a special case where x, y, z all are equal and they are equal to 0. A special case, trivial solution. Infinite means many solution, unique means one solution, and inconsistent simply means no solution. What's the condition to get a unique solution? The condition to get a unique solution. Now remember this formula. A inverse is what? 1 upon determinant of A, adjoint of A into B. This is numerator, this is denominator. Adjoint A into B numerator, determinant A is denominator. For unique solution, both numerator and denominator should be non-zero. Both numerator and denominator should be non-zero. This is not adjoint AB, it's adjoint A and then into B. For infinite solution, adjoint of A into B and determinant of A, what should happen? Both should be 0. For infinite solution, both are 0. For trivial solution, adjoint of A into B is 0, but determinant of A is non-zero. Such is a case for trivial solution. And no solution. When do you get no solution? We know whenever the denominator is 0, there is no solution. So let's put this denominator 0. Only the denominator 0. Numerator is not 0. Adjoint of A into B. This is non-zero. Only the denominator is 0. That means no solution. Now whenever question arises, find out whether it's consistent or inconsistent, or find out whether it has no solution or unique one solution. Unique means one solution. For no solution, determinant will be 0, as well as for infinite solutions, determinant will be 0. So if you get determinant 0, do not quickly mark no solution. You have to wait and find out adjoint of A into B. If adjoint of A into B is 0, it has many solutions. If it is not 0, no solution. So determinant A0 will signify two cases. Remember, infinite or no. Either it's many or no. Either it's fight or flight. Right? This chart will help you remember things. Furthermore, guys, before I go to the questions, couple of more things are left. Whenever we solve questions on this system of linear equations, we have three equations: a1x, b1y, c1z equal to d1, a2x, b2y, c2z equal to d2, a3x, b3y, c3z equal to d3. Now this is for order 3. That means having 3 variables, we can go for order 2 also. In our syllabus only the above equation can be represented in matrix form as follows. The above equation can be represented in matrix form as follows. A into x equal to b. Now what is A? A is your coefficient matrix. What is X? X is a column matrix. A will always be square. X will always be column which has variables in it. Equal to B is all your constants. B will always be column. You can check by order also. A1, B1, C1, A2, B2, C2, A3, B3, C3, X, Y, Z, D1, D2, D3. We need to find X, Y, Z. Our aim is to find X, Y, Z. What is the formula? From here, X is equal to, if A comes on the other side, A inverse into B, or better I may write it as X is equal to 1 upon determinant A into adjoint of A into B, right? That's how we find X. So guys, whenever a question is given, write it in matrix form. You know what's A, you know what X, what is B. Find out determinant of A. First step. Second step, you will find out adjoint of A. Third step, you will find adjoint of A into B. Multiplication of matrix. Fourth step, you will find out X by putting it in the formula, right? These 4 steps will give you the value of X. Now X is X, Y, Z. It will give you X, Y, Z. This is a lengthy method to solve using system of linear equations, but yes, this is very much what our CBSE wants to do. No Kramer's rule. Now the same question can be used in Kramer's method, but no. 2 order also can be done. This will be order 2, 2, 2, 2 by 1, right. One more thing is left, properties. Let's quickly discuss the properties, final few properties which we need to know to solve the questions. Summing up guys, final summing up. The first thing, after a lot of practice, solving questions, teaching to students, few points that we can bring in front of you, so it helps you directly in your examination. First point, determinant of a skew symmetric matrix. Determinant of a skew symmetric matrix of odd order will always be 0. If a skew symmetric matrix, take an example. Skew symmetric means diagonal 0, 3 minus 3, 2 minus 2, 1 minus 1. It's skew symmetric. Its determinant will be 0. You can find out directly. Odd order because the order is 3. What happens if it's an even order? Skew symmetric matrix of even order. Is it 0 again? No. It is a perfect square. It will always be a perfect square. Example 0, 0, 5 minus 5. Isn't it a skew symmetric matrix? Yes. What is its determinant? 5 5s are 25. It's a perfect square, square of 5. Always even order, it will be a perfect square. Next, determinant of a diagonal matrix. What is determinant of a diagonal matrix? For those who have attended my matrix session will be able to answer. If you have a diagonal matrix, its determinant is product of all diagonals, right? Product of all the diagonals. You simply multiply all the diagonals and get the answer. Now, related to this, we have, if you have an upper triangular or lower triangular matrix, determinant of upper triangular and lower triangular matrix will always be equal to product of diagonals. What is an upper triangular and lower triangular? I hope everyone knows. If not, let me quickly tell you. Upper triangular means everything above the triangle is present. 1, 3, 5, 2, 1, 9. Below this will be 0. That's an upper triangular matrix. Lower triangular means everything below the diagonal. Suppose 1, 3, 5, 2, 1, 9 is present, above it is 0, upper, lower. If you want to find its determinant, there's a direct way. You simply multiply the product elements, right? Next, how many? 4 properties done. Fifth one, the thing which I wrote in the beginning, definition of determinant expansion. Delta is equal to summation of Aij into Cij, right, where I and J belong to a particular row or column. But if this is summation of Aij into C, instead of Ij it has Ckj. I and K are not equal, right? These two elements are not equal. Then in this case it will be 0. Similarly, if delta is equal to summation of Aij into Cik, where J and K are not equal, again it will be 0. What it simply means is you are multiplying a element of some row and cofactor of another row. Element of some row and cofactor of another column. So when you have elements and cofactors of different row and column, the answer comes out to be 0. Sixth one, few special cases, guys. Few special cases, let's try to understand. This will help in solving questions on property. A short one before that. Determinant of AB is same as determinant of A into determinant B. No, nothing to worry in such a case. Yeah, special cases. Let's take special cases on another slide. Oh my god, why do I feel I have less time left? Right, no worries, no hurries. What is determinant of ABC, BCA, CAB? That means whenever you have a circulant form, circulant means they are going in circle. Can you see ABC? After B there is C, then A. In a circulant form, the answer is minus of A cube plus B cube plus C cube minus 3ABC. Remember it, used in various questions. Whenever you have a determinant like this, 1, 1, 1, A, B, C, A square, B square, C square. Answer is A minus B, B minus C, C minus A. Circulant form. Whenever you have 1, 1, 1, A, B, C, A cube, B cube, C cube, the answer is A minus B, B minus C, C minus A and A plus B plus C. Whenever you have 1, 1, 1, A square, B square, C square, A cube, B cube, C cube, the answer will be A minus B, B minus C, C minus A and AB plus BC plus C. Please make a note of this special things. Fine. Guys, the multiplication of any two determinant is same like multiplication of matrix. Suppose you have 3, 2, minus 1, 4 and 1, 1, 0, 9. How do you multiply matrix? First row, first column, first row, second column. In a similar way you multiply any two determinants, right? So that's multiplication of determinant equal to multiplication of matrix. 3 ones are 3, 2 zeros are 0. So 3. First row, second column, 3 ones are 3, 2 nines are 18, 21. Second row, first column, minus 1 and second row, second column, minus 1, 36, 35. Right, got it? Which point is this? Fourth, fifth point. Sixth point, guys, if we want to take differentiation, isn't that also a part of our syllabus? Not in CBSE, for competitive exams I'm talking. I'm covering this summary sessions from all perspectives, trying to touch everything that I can in 1 hour. Suppose a delta is given to you and you have to find its derivative. F of x, f1x, f2x, g1x, g2x. In order to find delta dash, that is first derivative, how we do? We will take derivative of one row at a time. At a time you will take derivative of only one row or one column. Suppose I take the derivative of one row and then keep that row as it is. First derivative of first row, second row as it is. Now first row as it is, then derivative of second row. At a time, derivative of only one row. That's a way to find derivative. And let's say we have to take integration. Determinant is f1x, f2x, lambda 1 and lambda 2 are constants. Lambda 1, lambda 2, lambda 1 comma lambda 2 are constants. If you want to find delta from a to b, integrate from a to b, you will directly integrate from a to b, f1x, a to b, f2x. You do not integrate constants, you keep the constants as it is. But let's say this lambda 1 and lambda 2 are not constants, they are some variables. This happens when lambda 1 and lambda 2 are constants. What if lambda 1 and lambda 2 are not constants? In that case, you will open the determinant, expand the determinant, and then integrate each term. The way you expand, same way you will expand any given determinant and assume this to be functions, product of diagonal minus product of off diagonal, write it and then integrate it. Cool. These are the things that I wanted to stress upon. Now we can quickly run through the questions. The questions are a secondary part of this sessions. The main part, the main aim is to cover the summary. Well, in the past 50 minutes, without wasting a single second, we have covered the entire theory of determinants. If anything you feel is missing, let me know in the chats. I have taken all the important points. The first question, if this delta is equal to 86, find the sum of these numbers. A has two values. A has two values. Find the sum of those values. As I said, the expansion of order 3, if you don't know, you can check here. How do we expand? I can see 0 in third row as well as first column. So it's your choice wherever you want to expand. Keep this plus 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 plus. This chart comes very handy to everyone while expanding. Suppose you are expanding along row 3. First element is 0, let it be. Second element should be negative, minus 4. Delete the 4 element having 4, row and column having 4. We have 1, 5, 2, minus 1. 1 into minus 1, minus 1, and 5 into 2, 10. Then we have a plus sign, plus 2a. Delete this, 1 into a, 2 into minus 2, minus 4. So a minus minus 4 will become plus 4. This is equal to 86. Simplify, minus 1 minus 10 minus 11 into minus 4, 44 plus 2a square plus 4 2s are 8a equal to 86. What's the answer, guys? You must have found out, dividing by 2 throughout. A square plus 4a, 86 minus 44 will be 42 by 2 minus 21 equal to 0. 7 3s are plus 7 minus 3 equal to 0. A equal to minus 7 or a equal to 3. We need the sum of these two numbers, that is minus 7 plus 3 will be equal to minus 4, option C. Option C was the answer. Next, A is given, theta is between 0 to 2 pi, then determinant of A is 0, 2 to infinity open interval, 2 to 4 open interval, or 2 to 4 close interval. Expand the determinant, guys. Before expanding, if you want to simplify, you can simplify, like if I add row 1 changes to row 1 plus row 3, isn't it? That will simplify. 1 minus 1 0, sin theta minus 1 plus 1 2. Rest everything is same. Minus sin theta 1 plus sin theta minus 1, minus sine theta and plus 1. Keep on solving, expand. Where will we expand? Along row 1, of course, makes sense because row 1 has 2 zeros. While expanding, what is the sign chart? Plus, minus, plus. The last element is positive. Take 2 positive, delete this row column. Minus sign into minus sign will be sine square theta, and 1 into minus 1, but already there is minus, so plus 1. Right, this is delta. Determinant value. We know sine theta always lies between minus 1 to plus 1 in 0 to 2 pi. So sine square theta will lie between 0 to 1. Positive values only, no negative values. Sine square theta plus 1 will lie between 1 to 2. And when you multiply this whole thing with 2 times sine square theta plus 1 will lie between 2 to 4. 2 and 4 included. So the answer should be option D. Do you agree? Very, very good. Next one, find the area of triangle. I guess this can be very easily done by all of you. Nothing great in it. There is a mod in area of triangle. Well, for finding area, considering it's always going to be positive, you remove the mod and simply expand the determinant. You expand the determinant and you'll get an answer. You want me to solve? 2 1 1s are 1. This is the speed that you should also keep while solving. 1 minus 8 minus 7 into 2 minus 40. Middle element negative. 1 minus 10. 1 minus 10 is minus 9. Minus 9 into minus 7 will be plus 63. 1. 8 minus 10 is minus 2. How much is this? Half. Minus 14 minus 2 minus 16 plus 63. 53. 47. 47 by 2 will be 23.5. Square units, do not forget to write the unit. It's an area, so square units is necessary. 23.5 is the right answer. Okay, let's quickly solve this using properties. The properties question has to be done. Evaluate this. Nothing else is given. Now, evaluation is there. Direct opening will be very difficult. I mean 16 into 100 into 180 minus 110 into 150, it doesn't make sense. That's why we learn properties. Try to observe. In properties, it's all game of observation. The property 4 is very important. So go back, revise that. Observation. Also the property 7 was important. Can we say 50 minus 82 will be, or 82 minus 50 will be 32, 58, 70. 32 is double of 16, 58 is double of 29, 70 is double of 35. So some connection we have seen. Once you get some connection, now it's la 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 la. Row 3 changes to row 3 minus row 2. Let's do it. Okay. When I change any two rows, when I am using this 7th property, elementary transformation, is there a sign change needed? No. When I am interchanging two rows or columns, sign change happens. Here I am not interchanging two rows columns. I am using the elementary transformation, no sign change. 16, 29, 35, 50, 100, 110. Let's do one thing. Row 3 changes to row 3 minus. That's it. Barabar hai. Right. Okay, this is 32, 58 and 70. One more transition and we are done. Row 3 changes to row 3 minus 2 times row 1. Again, property 7. Can you recollect? P7, elementary transformation. 16, 29, 35, 50, 100, 110. 32 minus 32, 0, 0, 0. If any particular row or column is 0, then the property 3 says this determinant is going to be equal to 0. There was another way also. You could have done row 3 changes to 1 by 2 times row 3. So 16, 29 and 35, when two rows are equal, still we get a 0. or two rows are in proportion. Here these two rows are in proportion. So property 4 says directly by using property 4 from this step, directly you could have said the answer is 0 because two rows are in proportion. Show that a plus b plus c minus b. Whenever you have such a type of question, that means the values are kind of symmetric. What we have in first row is something similar to second row, third row. What we have in first column is similar to second and third column. Not same, similar. To solve such a question, it's better we either add all of them, or let's do this. Column 1 changes to column 1 plus column 3 and column 2 changes to column 2 plus column 3. What are we going to get out of it? Because I am using the property 7, no need of determinant sign change. A plus b minus c minus b will give me a plus c, and these two will give me minus sign common a plus c, minus b cancels a plus c. Can you understand? Column 1 has been changed. Column 2 minus common b plus c, these two when added b plus c, these two I'll again get b plus c. The last column is as it is. Now because I am doing column transformation, I'll be continuing with column transformation only. From first column and second column, we can take a plus c and b plus c to be common. The common property, taking out common, you remember, minus 1, 1, 1, minus b, minus a plus b plus c. Okay. One more thing which we can do is, let's add column 1 and column 2. Column 1 changes to column 1 plus column 2 because we want to expand anyways, and the answer is almost there. Just to get more zeros, I like more zeros. The more the zeros, more the fun in expansion. A plus b, b plus c is there. I am adding two columns, 1 minus 1 0, minus 1 1 0, 1 plus 1 2, minus 1 1 1, minus b minus a plus b plus c. Now the expansion, expand along column 1 of course, because it has two zeros, a plus b, b plus c. In the bracket this will be 2 times, hide this row column, you will get minus 1 into minus a plus a, minus of minus plus b. The answer is 2 times a plus b, b plus c, c plus a. That's the RHS. Hence, done, done, done. Understood? Got a very good, excellent, super. Next one, it is system of linear equations. Solving system of linear equations. The simultaneous equations have only one solution when k value is what? Minus 2, minus 1, 0 or 1. Now because it has only one solution, that means it is unique. And when it is unique, remember that chart, the first thing was unique, infinite, trivial, no. Unique meant numerator, denominator both non-zero. That means determinant should not be 0. That is for sure what we know about unique. Let's try to write this equations in a coefficient matrix. So coefficient of xk, 2y minus 1. Not 2y, just 2. All the coefficients we are writing. Okay, here the coefficient of x is missing. Just coefficient of y present, coefficient of z present. There, only coefficient of z is present. Okay, these two are missing. Let's do one thing. Instead of, taking this matrix, we will take a determinant directly. Y. K 2 minus 1, 0, k minus 1, right. This is my A. All the coefficients nicely written. Now this A, this determinant should not be 0. Let's try to expand this determinant. Can you see where is the maximum number of zeros? Along row 3 or along column 1? Your choice. If I do it along column 1, k, hide this row column, k minus 1, k minus 1 into k minus 2 2 zeros are 0, is not equal to 0. K minus 1, K minus 2 should not be 0. That means K should not be 0, K should not be 1 and K should not be 2. K should not be 0, not be 1, not be K plus 2, this is, that means should not be minus 2. That means K can be what? What can be K? It can't be 0, can't be 1, can't be minus 2. It can be minus 1, of course. It can be minus 1, got it? Very good. For what value of K the system will have? Infinite solutions. Unique infinite. Now for infinite we knew that determinant should be 0. Adjoint of A into B should also be 0. Let's first go with the determinant. Before I go for adjoint, determinant should be 0. What is determinant? Substituting 1 minus 1, 1, 2, 1 minus 1, minus 3 minus 2K and 6. Simplifying it, getting the value of K, not to 0, 3 or minus 1. Of course, it can't be option A because it is equal to 0, not equal to. Directly you can find, or you can just add these two columns to get maximum zeros, your choice. 1, 6 minus of minus 2K, minus of minus plus 1, 12 minus 3 and plus 1, 2 2s are minus 4K, minus of minus plus 3 should be 0. 6 minus 2K, 12 minus 3 is 9, minus 4K plus 3 is 0. How much is this? 6 plus 9, 15, 18. Minus 2 minus 6K equal to 0. K is equal to 3 is what I am getting. Is it correct? I don't know. Let's check. C is the answer. Oh yes. Guys, if you find the speed is more, you can always slow down. There's nothing wrong in it. These two determinants are equal. Find the value of X. How do we equate in determinants? It's not like matrix where you equate the corresponding elements. For equating the determinants, we solve the determinant. 3 4s are 12x minus 7 plus 14. Product of diagonal minus product of off diagonal. 12x is equal to minus 10 minus 14. X is equal to minus 2. Option D. Lalao. Okay. If the determinant of matrix A of order 3 is of value 4, then value of determinant 3A will be what? So what they've given us the order is 3. Determinant value is 4. We need 3 times A. Value of determinant 3A. According to the formula, determinant KA is K raised to N times determinant A. So here also it will become 3 raised to N is 3 times determinant A. 3 3s are 20. 3 cube is 27 and determinant A is 4. 27 4s are 108. Option A. Is that correct? Right. As this is the homework question, you can solve and comment and let me know whether you could solve this question, yes or no. Options are half, 1 by 3, 1 by 4, 1 by 5. For this, determinant A is 4, order is 2, determinant of A inverse will be how much? With this, we finish off the chapter well in time. Kudos to all of you. Let's meet in another session. Till then, keep smiling, keep your energies positive always, and feel free to talk to me via the comment section. See you. Bye-bye. Keep smiling. Signing off.